right, now that we've learned polynomial long division, I'm now going to show you a technique called synthetic division. It's a type of polynomial division under very special circumstances. The special circumstance is that the divisor must be a first power polynomial. See, with polynomial long division, we can divide by quadratics. For example, if this said x squared plus 5, we could do that with polynomial long division, but we cannot do that with synthetic division. Synthetic division, your divisor has to be a linear factor. Okay. All right. So there are three phases. Okay. I call it the first phase. I call the setup. The second phase I call the execution, and then the third phase I call the interpretation. Okay. Now, it's going to take me a few minutes to explain it to you, and you may actually in that time say, oh, this is taking too long. I'd rather just do polynomial long division. Trust me when I say when you start doing synthetic division, it is much faster than polynomial long division. Let's do the setup first. Okay, you're going to draw what I call a half box, and it looks like this. Okay, it doesn't really look like a half box usually. There we go, half of a box. Okay. Then to the right of it, you're gonna sort of leave space for a line here. Don't draw this, but you're gonna leave space for a line here. Then you're gonna leave space for a line here. Then you're gonna draw a horizontal line. Okay. So basically, what I do is I just come down a little bit and I draw a horizontal line. And you're gonna write some stuff here, and you're gonna write some stuff here, and you're gonna write some stuff here. There are 3 rows in synthetic division. Okay. In the first row right here, what we're going to write is some numbers. The numbers we're going to write are just, not letters, just the numbers. We're going to write the coefficients from the dividend, okay? So we're going to write 2, 13, 11, and negative 14. It's important that you understand where these came from. The 2 came from there, the 13 came from there, the 11 came from there, and the negative 14 came from there. Okay, we're just taking the numbers from the dividend. Then what we're going to do is in this half box, we're going to put one number. That number is going to be the 0 of this factor. So it usually winds up being the opposite of this. So this is plus 5. So in the half box, we're going to put minus 5. Okay, so this plus 5, we switch the sign and we put it in this half box. Okay, that is the setup. All done with the setup. Now we're going to move on to the execution. The first thing you do is you're going to take this first number here, the 2, and you're going to bring it, well, let me do that again. You're going to bring it way down below the line. Okay, you're going to put the 2 down here. You're taking the 2 and you're moving it down below the line. Okay, that's the first step. The next thing you're going to do is you're going to multiply this number times the number in the half box. So we're going to do 2 times negative 5. And then we're going to put it in the above the line in the next column over. Okay? So we're going to take the 2, multiply it by the negative 5, and we're going to put it right there. Okay? So 2 times negative 5 is negative 10, and we're going to put it right there. Negative 10. There we go. So 5 times 2 equals negative 10. Okay? All right. Now what we're going to do is we're going to add these two numbers together. And that's basically how this goes. We multiply and then we add. We multiply and then we add. We multiply and then we add. That's the whole procedure for synthetic division. So 13 plus negative 10, it's the same thing as 13 minus 10, but let's say 13 plus negative 10 is 3. Now we're going to take this number, 3, and we're going to multiply it by negative 5, just like we did with the 2. Okay, so 3 times negative 5, and then we're going to put it right there, just like we did with the negative 10. We moved it over. Okay, so 3 times negative 5 is negative 15, and we're going to put it right there. Okay, so negative 15. Then we're going to do the same thing. We're going to add. Okay, we're going to do 11 plus negative 15, which is negative 4. Then we're going to multiply the negative 4 times the negative 5, and that's 20. We're going to put it up here. Then 20 plus negative 14 is 6. Okay? That's the execution. Okay? And then what I do is I always put another half box around this one, and I'll explain that in just a minute. Okay? So here's what I'd like to do actually, is I'd like to do that whole thing over again because I think it'll be easier to watch. So this is the setup. Now we're going to do the execution. It goes really fast. We're going to bring down the 2. We're going to multiply the 2 times the negative 5. That's negative 10 and put it up here. Then we're going to add 13 plus negative 10, which is 3. Then we're going to multiply 3 times negative 5, which is negative 15. Put it here. Negative 15 plus 11 is negative 4. Negative 4 times negative 5 is 20. We're going to put that here. 20 plus negative 14 is 6. That was pretty fast, right? That is how fast synthetic division can go. And then we're going to put a little half box around the 6. Now we're done with the execution. Now we're going to move on to the interpretation. Okay, this number in the half box right here, all the way on the end, that's the remainder. Okay, it's really easy, isn't it? It took us a long time to find the remainder in polynomial long division. So we're going to want to identify our q of x, or just q, and our r. Here, our remainder is 6. Well, how do we identify our q? Well, these numbers are what give us our q, and here's how it goes. You're going to write this number 2, and it's going to be x to a power. But what's the power? We're going to go down 1 power from what we started with. We started with x to the 3rd, so we're going to go to x squared. Then this, the next one over, so this is x squared, this is x to the 1st, this is our constant. So it's 2x squared plus 3x minus 4. Okay? 2x squared plus 3x minus 4. Okay? That is how we identify, or that's how we interpret the results of our synthetic division. So the first thing we do is we go up to the original, we go to the lead term, we look at the degree. The degree is 3, and we're gonna do the degree minus 1. Okay? Degree minus 1. So 3 minus 1 is 2. That's going to be our new degree. That's going to be the degree of our quotient. So it's going to be 2x squared. That comes from here. Then we're going to take our 3, and it's going to be plus 3x, and then minus 4. Okay? And that's synthetic division. Here's our q, and here's our remainder, just like we did in polynomial long division. Let's do another example. Okay, this is actually an example from our video on polynomial long division, and we already know the quotient and we already know the remainder, but we're going to do it with synthetic division this time, okay? All right, so what I'm going to do is I'm going to do my half box. I'm going to draw my line, and in the half box, I'm going to put the opposite of this. This is x minus 2, so I'm going to put a positive 2. Then I'm going to take my coefficients. The coefficient of x cubed is 1. The coefficient of x squared is negative 5. The coefficient of 10x is 10. And then the constant is negative 8. Okay, so those are all my numbers. I've done my setup. Now I'm going to do the execution. I'm going to bring the 1 all the way down under the line. I'm going to multiply 1 times 2, which is 2, and I'm going to put it here. 2 plus negative 5 is negative 3. Negative 3 times 2 is negative 6. Negative 6 plus 10 is 4. 4 times 2 is 8. And 8 plus negative 8 is 0. And you can see our remainder is 0. And our degree of our original was the third power. So now this is going to become 1x squared minus 3x plus 4. And look over here, that's exactly what we had. And that's how we use synthetic division. Okay, here's a new example. We're going to draw our line in our half box. The opposite of negative 3 is positive 3, so we'll put a positive 3 in the half box. We'll bring down a 4, a negative 12, a positive 5, a negative 22, and a positive 19. We'll bring this line over a little farther. That's the setup. Now the execution. We'll bring down the 4. Multiply the 4 times the 3 is 12. 12 plus negative 12 is 0. 0 times 3 is 0. 5 plus 0 is 5. 5 times 3 is 15. 15 plus negative 22 is negative 7. Negative 7 times 3 is negative 21. And negative 21 plus 19 is negative 2. And so our remainder is negative 2. And our quotient is, we started with a power of 4, and now we're going to go down to a power of 3. So that's 4x to the third power. And now look at this. This is a 0 for the x squared. So basically we have 4x to the third power plus 0x squared plus 5x minus 7. But look at this. There's no reason to write 0x squared. We can skip that one. We can leave it out. So we're going to leave out the 0x squared, and we're just going to write 4x cubed plus 5x minus 7. And that's our quotient. Let's do a couple more examples. All right, here's the original one we did in polynomial long division. We already know what q is. We already know what the remainder is. So let's go ahead and set it up for synthetic division. In the half box, we're going to put the opposite of negative 7, which is positive 7. We're going to bring down the coefficient of x to the fourth, which is 1. Let's not forget to draw our horizontal line. Then we're going to bring down a negative 5. Negative 5. Then we're going to bring down a negative 17. Then we're going to bring down a positive 20. And then we're going to bring down a positive 13. We've done our setup. Now we're going to bring down the 1 under the line. 1 times 7 is 7. We'll put that under the negative 5. Negative 5 plus 7 is 2. 2 times 7 is 14. 14 plus negative 17 is negative 3. Negative 3 times 7 is negative 21. Negative 21 plus 20 is negative 1. Negative 1 times 7 is negative 7. And negative 7 plus 13 is 6. And that is our remainder. Sure enough, our remainder is 6. And then our original power was a power of 4, so we're going to go down to a power of 3. So 1x to the third power is just x to the third power, plus 2, and that'll be an x squared, minus 3, that'll be a minus 3x, and then a minus 1, minus 1. And sure enough, that's what we had for our quotient. Synthetic division is so easy and so much fun, we can even do it with fractions. Let's say our divisor is x minus 2/3, and this is what we want to divide. All right, so we'll go ahead and set up our half box. We'll draw our line. Our divisor number is negative 2/3, so we're going to put positive 2/3 in the half box. We're going to bring down a 6. We're going to bring down a negative 16. We're going to bring down an 11, and we're going to bring down a negative 2. All right, now let's do the execution. We're going to bring the 6 below the line. 6 times 2/3, well, 2/3 of 6 is 4. So we're going to put that here. 4 plus negative 16 is negative 12. Negative 12 times 2/3, 2/3 of negative 12 is negative 8. Negative 8 plus 11 is 3. 3 times 2/3, well, 2/3 of 3, that's 2. And 2 plus negative 2 is 0. And look at this, good news. We got a remainder of 0. We love it when we get a remainder of 0, by the way. And then our quotient, it started at the third power. Now this is going to be 6x to the second power. 6x to the second power minus 12x plus 3. Okay? I'd like to do just one more example. Once again, this is another example from when we did polynomial long division. So we already know the remainder. We already know the quotient. Let's see if we get the same thing. In the half box, we're going to put the opposite of this plus 4. So we're going to put a negative 4 in the half box. The coefficient of x to the third is 1, so we'll bring a 1 down. The coefficient of x squared is also 1, so we'll bring another 1 down. Then we'll bring down a negative 7. Then we'll bring down a 25. All right, let's start it off. We're going to bring down the 1 below the line. We're going to multiply 1 times negative 4. That's negative 4. Negative 4 plus 1 is negative 3. Negative 3 times negative 4 is positive 12. 12 plus negative 7 is 5. 5 times negative 4 is negative 20. And negative 20 plus 25 is 5. So our remainder is 5, just like we got here. And since we started with x to the third, we're going to go down to x to the second. So this is going to be 1x to the second, or just x squared, then minus 3x, then plus 5. And sure enough, that's exactly what we had for the quotient. Okay, I hope you are feeling confident with synthetic division. With just a little bit of practice, maybe about 7 or 8 questions, I think you'll be really good at it. And I'm going to give you lots of opportunities to use synthetic division, because the next couple things we're going to learn, the remainder theorem and the factor theorem, are going to allow you to use synthetic division so that you can better understand it.